Hey
What's up,
guys,
guys?
welcome.
Welcome back. Partial fraction. This will help you in your A level when integrating. So remember to hit that subscribe button for more awesome content. Mr. Pulsberg.
And like and get us on the
Soon to be
trend.
St. George's channel.
Soon to be.
No, I won't. I'll just leave this up, and like all my others, it will just
Making you.
exist in the ether. Right. So basically, this is what we're going to do. So we look at this and think, right, what must the denominators be? And
They must multiply to make.
exactly. So what we're doing is, I hope you're focusing. We look at factorizing 15. So there are more than one option to this. That's why I said what it could be. But I'm going to, because I know what I've got in my head, I'm going to factorize this to 3 times 5. Okay. What we're then going to look at is say, well, what impact does that have on the numerators? Okay. So what would happen here when I end up with the denominator factorized? So if you think about it, if I had a over b, to have it like this, it would actually be b times d, and therefore this would be ad, plus this would be cb over bd. All right. So in this case, what would we have? We'd have a times, so the d is the 5, it must have been 3.
You want us to write this down as well?
Up to you. Let's talk it through first. But if it was a 3 and a 5, we would then multiply 3 and 5 to make 3 times 5 15, yeah? So the two fractions would be something over 3 and something over 5.
Yeah.
Happy with that?
5,
2 and 1.
So, yeah, remember what we're trying to do is how would we link what we're going to do with partial fractions to this? So we would have, I'm going to say it's a value A and a B, and I'm looking for those two numbers. Yeah? All right. So how would I get that? Well, what we did to get the 3 times 5, obviously this would then get multiplied by the 5. So I would have 5a plus 3b. Following that through?
Yeah.
Okay. That's what you would do. So we would do 5a would then be over 15 plus 3b would be over 15. Right. Now here's the bit that we then would need. So get rid of this. So we can now equate the 13 to the 5a plus 3b.
Yep.
All right. Now this is where it's slightly harder in this case than what you're going to be doing, is because we now need to figure out what values of a and b could be. Now in this case, I'm going to just have a bit of a starting guess and say, what if a was 1? What would b have to be? Well, that would make it 5 plus 3b equals 13.
Yeah, 8 over 3.
Which means 3b would be equal to 8, which is not going to work. Right? Make sense?
Yeah.
What would therefore happen? So I'm going to have to pick a different one. So what if when a is 2? Then it would be 13 is 10 plus 3b. Well, that's nice, because then I've got 3b is equal to 3, which means b is equal to 1. Okay? So I've then found out what my a and b are. Therefore, my fraction would be 2 over 3 plus 1 over 5. So we can, you've probably never thought of doing that in the past, but I've just shown you what we can do with fractions, we can split a fraction back up into a potential. Not worried about whether you write that down or not, just trying to give you a heads up as to why we're doing what we're doing. So, let's have a look at this particular question. So we've got a fraction here, which is 2x plus 3 divided by already in factorized form. Right? So we're just going to make, do you want to write that down? So you've got our pause. So, what did we just look at with the fraction? Well, we looked at it and said, the basic fraction here, if we've got this in factorized form, that meant we had something divided by one of those factors plus something else divided by the other factor. That was the 3 and the 5 bit, yeah? We've just got to figure out what the A and the B are. Right? But we've actually got to then to be able to solve this, what we need to do is put this and this as equivalent forms.
Yep.
So we're then going to say, I'm going to multiply through, so this will be a times x plus 2 is over x plus 1 times x plus 2 plus b, so we're kind of doing what we would do if we were going to actually add these fractions together. Okay. Okay. So those two are now equivalent to each other, yeah? That's what you would do. If these were the two fractions originally, you would do this to make common denominators and then just add them together. So just like previously, what statement can we now make?
2x plus 3 equals
2x plus 3 equals
a.
a times x plus 2 plus b times x plus 1. Okay. So we've got to that point. So that all looks very similar to what we were doing with the numbers, yeah? Now what we try and do you remember before I kind of just guessed, I went with A is 1, B is whatever. Did it work? This is where it's slightly easier to do it, because what we want to do to solve this, we're going to pick a value for x that we know eliminates one of the two parts. All right? So I'm going to go with what if happens when x is
What minus?
minus 1.
Oh, okay.
Why minus 1?
Because it equals 0.
Because that makes this 0, so b times 0. So then we've got 2 times negative 1 plus 3 equals negative 1 plus 2 is 1, so that's a. So I've now got a is negative 2 plus 3 is 1, so I've got a is 1. How do you think we find the b?
Do the same.
Do the
The
same
other
thing.
one.
So when
we
x
just
is minus 2, hey?
Do we just decide x to be minus 1?
Yeah,
Or-
why did I decide that?
Oh, because of the bracket, the first.
The bracket. I used
You
x
don't
plus
just plug
1.
A in.
You could, I guess, but I mean, this is just as quick and easy, I think. Because now, obviously, minus 2 makes the a bit. So now I've got 2 times negative 2 plus 3 equals b. Negative 2 plus 1 is minus 1, so it's minus b. So that's minus 4 plus 1, so minus 1 is minus b, which means b is 1. So we're now pretty much finished up. So we can say that 2x plus 3 over x plus 1 times x plus 2 can be rewritten as 1 over x plus 1 plus 1 over x plus 2. Done. Okay.
Is that just the questions you would get?
So, like I said,
Or does it get much
you
higher
don't
than
you don't necessarily only have to write as a partial fraction. And they won't even tell you to do a partial fraction. So what they'll do is say integrate this,
that? Yeah.
and you need to know. Oh, I can't do that. What do I need to do? I need to put it into partial fractions, and then I'm kind of, not for now, but we could do it maybe next time. Have a think about it. You actually can already integrate those separately, right? So if you were asked to integrate all of that with respect to x, all right, that's going to be a struggle. But integrating that with respect to x, integrating that with respect to x, is going to be much easier for you to do. Hence, that's why we're doing it. Actually, I don't know whether have we done these ones yet. No, I think this we're going to do substitution. The reason why this is now much easier is because when you integrate 1 over x with respect to x, you get, anyone know it already?
1 over x.
You get the natural log of x.
Yeah, I knew that.
Yeah, I think maybe a little bit ahead of myself. We don't know that yet, but you will do. So you can see from that, no idea, but these are just going to be the natural log of x plus 1 plus the natural log of x plus 2, nice and easy and done. Okay, so that's why we're doing it. Where I don't know, I'm going to go back to the starting point so you can write your notes, because the next example relies on you having read all of that. So I want to write it. Okay, so we're going to see whether we can.
Factor out x and then take away x.
Yeah, we're going to see whether we can simplify first.
Yes, because it's plus 2.
Well, let's have a look. How can we factorize? So factorizing the top.
It's like
Okay. So the denominator is going to be x times x squared minus 1, which you can difference of 2 squares that. So we've got x times x plus 1,
X1.
x minus 1. So we've, well, we can factorize it as x squared times x squared minus 1 plus 2, okay, which
Just takes away those 2.
well,
Oh, wait, no, because there's a plus
we're
2.
still exactly, the plus 2 is a potential issue, so you need to know what to do here. There's no point me writing up here. So what we're going to do is we're going to just split the fraction up, not partial fraction style, but literally just split the fraction up into its 2 parts with a plus in the middle. One side is going to be 2 over x times x plus 1, x minus 1. And the other side is going to be
x squared and
x squared times x squared minus 1 over x times x squared minus 1.
Oh, so just
cancel those.
It's just x. No?
So we've then got just x plus 2 over
I know you're gonna partial fractions in a second.
We've done
No,
the
it
partial
was so
fractions.
cheeky.
well,
No, just single.
do we need to?
We're trying to simplify.
What?
Just trying to think if I made a. So this part now. Gives me curves and slide it up. So we're now going to use partial fractions on this bit. So don't forget this bit exists. So we're going to go
Hello.
2 over x times x plus 1 times x minus 1. What's that going to be equivalent to? It's going to be a over x plus b over x plus 1 plus c over x minus 1.
Just
Right. So Gabe was mentioning, aren't we going to struggle? But you'll see why it's not an issue. So what do we have to do first? Well, we have to put this side in a way that as if we were going to add it all back together to make this.
Yep.
So we're going to have a times
x squared minus 1.
x plus 1 times x minus 1 plus b times x times x minus 1 plus c times x plus 1. All of that's going to equal 2. I've taken a bit of a shortcut there, so I hope that all makes sense. So this one you have to multiply by both of those to make the denominator the same. This one by those two, this one by those two. Okay, so here's what happens then.
Still the same test.
Okay.
That's still the same.
Still the same question. Yeah, we're still
Yeah, yeah.
dealing. Yeah.
It's this side you just have to
I've got the same.
rewrite it as x plus 1 and x minus 1.
I've looked at it.
Okay, so what do we do? What values of x do we pick? Well, if you'll notice, look, that if I pick a value of x being 0, that wipes out b and c. So I then get 2 equals 0 plus 1 is 1, 0 minus 1 is minus 1. So that gives me minus a, so a is minus 2. If I pick x is positive 1, that gets rid of my a, but also gets rid of my b. So then I get 2 is equal to 1 times 2 is 2, 2c, which means c is equal to 1. Okay, and what's the final one I need to do?
It's
So x being equal to negative 1. Gets rid of this one, gets rid of this one, so I get 2 is equal to minus 1 is minus 2. Minus 2 times minus 1 is positive 2, so 2b, so therefore b is equal to 1. Okay. So then we're back to here then, which means we have minus 2 over x plus b is 1 over x plus 1 plus c is 1, so 1 over x minus 1. But what must we remember? The x plus. So we had x plus, so I'm going to very big minus. Yeah, we remember I said don't forget this bit. Okay. So again, this that we started with is very kind of difficult to integrate. We won't be expected to do it in that form. But once we've got it written in this form, all three of those will be very simple to integrate, right? Okay.
How would you do that?
Well, like I said, these ones
2 over
eventually.
x is just 2.
Yeah, I know.
This would be x squared over 2. These will be,
Yeah, I got those ones.
well, eventually, like I said, I think I was a little bit ahead. Thought we'd already done it, but we haven't. These are just going to be the natural log of,
Okay.
basically. But because we haven't covered that, don't worry about it. So I'm looking ahead a little bit, but that's why this will be useful to you. All right, so